Hey everybody, hello algebra fans and all those who love learning about quadratic equations. Today's lesson is going to cover solving quadratic equations by factoring. There are a number of ways to solve quadratics, and factoring may be one of the most basic because if you know how to factor and if the equation is factorable, this can be a really nice, kind of a quick way to get to those solutions and those x-intercepts if you're looking for parts of a parabola. So I thought before we start off, we could look at just a couple quick reminders on how we factor quadratic equations. Remember to always find the GCF, greatest common factor, first if you believe one exists in your problem. In this problem here, 15x squared plus 25x. I see a GCF of 5 and then an x in both terms. So 5x can be factored out. And if I undistribute the 5x, I'm going to have 3x, and then it looks like I'll have plus 5 inside of the parentheses. So I can double check that by simple distribution to make sure I didn't make any errors. If I multiply that back out, I'll get 15x squared, and then 5x times 5 is 25x. So I factored it correctly, and I can be pretty happy about how that looks. Trinomial factoring is when we're going to build this sort of two parentheses skeleton, and there's only one way to get x squared, so I'm going to put an x and an x in the front of my factorization. And then I'm looking for two numbers that multiply to the 24 in the back. So multiply to that number, but the two numbers I want must also add to the middle term. I want them to add up to this 10x. So what are two numbers that multiply together to give me 24, but when I add them, I get 10? How about we try 6 and 4? 6 times 4 is 24, and then 6 plus 4 would be 10. So I've got my factorization of x plus 6 times x plus 4. In order to have success solving by factoring, you've got to make sure you know how to factor. Fortunately, by now, we are experts at factoring or approaching the expert category at factoring. The way to solve equations now using factoring is to use a property that we call the ZeroProduct property. And it essentially says this, that if a and b are real numbers and the product of the two numbers equals 0, then either a has to be 0 or b has to be 0. One of those must be true in order for your equation to be true. And the reason that helps us solve by factoring is if I have, for example, an equation that's been factored for me already, like this, then I can simply take each factor separately and set them equal to 0. Because if 2x times the quantity 3x plus 1 multiplies together to 0, then I know one of those has to be 0. Either 2x is equal to 0, or 3x plus 1 is equal to 0. And so now what I'll do is solve each one of these little mini equations separately. Divide by 2, and I'll find out that x over here is equal to 0. Subtract 1, and then divide by 3. So I have two solutions of x equals 0 and x equals -1/3 for that problem. I'm going to skip ahead to the one here on the end. This one was a trinomial that was factored, but again, it's kind of nice. The problem has been factored for me. So all I need to do is apply the ZeroProduct property and set each one of these factors equal to 0. And then solve each equation separately. On the left over here, x is going to equal 10. Over here, add 4, and then divide by 3 to get a solution of 4/3. So again, two answers, x equals 10 or x equals 4/3. I want them both because both could be true for x to equal in order for the equation to be true. So those examples are some of the most basic because the functions or the problems have already been factored for you in the equations. Let's take a look at some that are a little bit more complicated because they haven't quite yet been factored for us. And one other rule just to know here is that before we start diving into using this ZeroProduct property and factoring, make sure first that all expressions are on one side so that the equation itself is equal to 0. we want to set one side equal to 0 in order to use this step. And then we'll factor, and then we'll apply the ZeroProduct property. So I kind of like this little collection of steps right here to help us and to guide us through these problems. So diving in, let's take a look at number 1. Solve each equation by factoring. And by the way, these are equations. You're going to see equal signs all across these examples. And what do we do to equations in mathematics? We solve them. The verb you'll see in the directions is solve, and the items that we are solving are going to be equations. So look for that equal sign and make sure that you carry down the equal sign with each step of work. Now in number 1, I noticed that there's a GCF I can factor out. Looks like a 2 and then an x. So 2x, undistribute the 2x, carry down equals 0. Don't lose that part of your equation. So x plus 4 is how that factorization is going to look. You can check by distributing back. And then apply the ZeroProduct property. 2x equals 0, or x plus 4 is equal to 0. So I have two answers here of 0 and negative 4. Box them both in. Right below it, problem number 3 has a negative leading coefficient. Now, when that happens, I would argue that it's nice to factor out in your GCF the negative. So include that negative in your GCF factorization. So in other words, I see, let's see, negative 4, I think 4x is going to be that GCF. And again, make it negative. So then I'm going to have a positive 5x left over in the parentheses, and then a minus 1. Check that by distribution. It looks like I'll get a negative 20x squared, and then a plus 4x equal to 0. So the factorization looks good. And then either this is equal to 0, negative 4x, or my 5x minus 1 is equal to 0. Divide by negative 4, we're going to still get a 0 for a solution. And over here, I'm going to add 1 and divide by 5. So x equals 0, x equals 1/5. I'll do a couple more examples for you. Again, a reminder, get one side of the equation equal to 0 before we start to factor with the ZeroProduct property. It's nice to have the terms in descending order as well. That leading coefficient should be up in front. And then factor, and then apply your ZeroProduct property from there. So let's look at a couple of these here together. How about we skip down to number 3? Number 3, it's not a GCF problem. I'm wondering, can I factor this quadratic? How about 30? How about 10 times 3? Because I can get a negative 13 if I make them both negative, and the negative 10 times negative 3 still is positive 30. So there's the factorization, and by the ZeroProduct property, I can write down that x minus 10 equals 0, or x minus 3 is equal to 0. Solutions are 10 and 3 for that problem. And remember that what we found is actually the two x-intercepts of the parabola. If I graph this, it's going to open up because I have a positive leading coefficient. A is greater than 0. And the x-intercepts are at 3 and at 10. So my parabola might look something like this, with a 3 right there, and then over here would be a 10. So when we find solutions of quadratics, we also have found the x-intercepts of the function. Let's look down here at 5. X squared plus 16x plus 64 equals 0. That one is a special pattern. I recognize that as x plus 8 times x plus 8 equal to 0, or I could write that as x plus 8 quantity squared. So here, my solution will just be x plus 8, my factor x plus 8 equal to 0, leading to one answer of negative 8. There's an example where the quadratic equation only has one solution. And if that's the case, graphically what's happening is, here's -8. The parabola just comes and sits right down on top of that little x-intercept. That is the only x-intercept in the picture. So only one solution. And then finally, sort of the most challenging problems, not that they're that difficult, but just a little added twist. You may have a GCF kind of buried within here. I see a GCF of x in this final equation. So factor out an x. I have x squared left over plus a 3x and then minus a 40. Double check by distribution to make sure that your factoring was correct. X cubed plus 3x squared minus 40x. Then this can be factored further. Two numbers that multiply together to give me -40. How about we try 8 and 5? And I have a +3, so let's make the 8 positive and then the 5 negative. And if I check with inners outers, I'll get a +8x, a -5x, and that'll give me the middle term there of +3x. Now here, in this case, I'm going to have three solutions. X equals 0, x equals -8, or x minus 5 equals 0, so I'm going to get x equals +5. 1 and 2 and 3 solutions altogether. So that is how you solve equations by factoring. Get one side equal to 0, factor, and then apply the zero product property to find those solutions. Hope that was helpful for you today. Good luck with the rest of your work.